All right, so now I want to look at section 6.1, and it's about laws of sines. And so everybody's familiar with right triangle trig, and what we can do when we have a triangle with a right angle. But what I want to talk about are things that deal with oblique triangles. So an oblique triangle. And that just really means that it's not a right angle. So it's an obtuse triangle, or an acute triangle. All right. And so our laws of sine, and so we can still answer questions about these by using things like sine and then in 6.2 cosine. Okay. But if we have a triangle that looks something like this, and this is just a generic triangle here, and I call this angle A. I'm going to call this C. I'm going to call this angle B. And then the side opposite of the angle will be the lowercase letter. So lowercase a, lowercase b, lowercase c. And then this triangle has a height right here at the middle. That is, we call h. All right. And so our laws of sine say that our side divided by the sine of the angle will be equal to the B side divided by the sine of B. And then C will be equal to the sine of the angle C. Okay, so I'm using my capital letters to denote my angles, and then my lowercase letters to denote my sides. All right. And then our height, h, can be found by taking the B side and multiplying it by the sine of A. Okay. And we're going to let A control our angle. So A kind of dictates if we have an obtuse or an acute triangle. Okay. All right, so let's do an example of this here. So let's say that we have a triangle. Again, I'm just kind of generically drawing this, but I've got angle A, B, and C, and then I've got lowercase a, B, C. Okay. And I say that angle B is 45 degrees. Angle C is 105 degrees. And the side B is equal to 20. Okay. So just by knowing these, I need to fill in, I need to solve for capital A, I need to solve for lowercase a, and I need to solve for C. And so, just starting with angle A, if you remember that the sum of triangles, there's sum of the angles of a triangle, is 180 degrees. Okay, so to solve for A, I really just have to figure out what angle makes this triangle equal 180 degrees. And so what I can do is 180 minus 105 minus 45. And I get that angle A is 30 degrees. Okay. So that is 30 degrees for angle A. All right. Now to solve for A, lowercase a, I'm going to say that A divided by the sine of its angle, which is 30, will be equal to, and I'm going to use B here because I have a side length for B, 20 over the sine of 45. I'm just going to multiply over by sine of 30 to say 20 sine of 45 times the sine of 30. Okay, I want to make sure that my calculator is in degrees when I do this. And so I plug it in the calculator and I get 14.14. Okay. All right. And so now the last one we need to solve for is side C. And I'm going to use the B side again because I have exact measurements for that. You don't have to. You could use A. The only thing is, because A was rounded, it could throw your answer off. So I always try to use ones that I have given values for. So I'm going to say C is sine of 105, or C divided by the sine of 105 will be equal to the B side, so 20 over the sine of 45. All right. So multiply over and plug it in the calculator. Again, make sure you're in degrees when you do this. And so plug it in the calculator and I get 27.32. Okay. So that would be an example of how to solve for each of those missing parts. Okay. And that's all you're going to be doing for this homework section is just solving for these. But I do want to touch on an example that you could run into. All right. So let's suppose that we have a triangle that has the angle A being 130 degrees. Okay. Angle or side A is 155 degrees. And side B is 280 degrees. Or 280, excuse me. Angle A is 130 degrees, side A is 155 length, and B is 280 length. Okay. So one thing that happens, and you may remember this from like a high school geometry class, the largest side, or longest side you could say, will be opposite the longest or the largest angle. Okay. So if we notice, if we draw this triangle here, A being 130 degrees down here, 155, but 280. All right. That would mean that my angle B would have to be larger than A. However, because A is 130 degrees and I can't exceed 180 degrees, then this would mean that no triangle is possible. Okay. With these measurements. All right. So that is just something to be on the lookout for, that there's a chance that you won't get a triangle possible. However, let's say that I wanted to solve this. Okay. And so maybe I didn't recognize that rule, so I go through the solving. So I say that 155, so I'm trying to solve for B here. So I'm going to say 155 over the sine of 130 is equal to 280 over the sine of B. Okay. Multiply over by the sine of B, multiply over, so I get 155 sine B is equal to 280 sine 130. I divide over by 155, so I get sine B is equal to 280 sine 130 over 155. To get rid of my sine, I'd use arc sine or inverse sine. So that is to say that B will be equal to the inverse sine of 280 sine 130 over 155. Plug that in the calculator and you get undefined because it is not possible. Okay. So again, if you recognize that rule, great. If not, if you try to do the algebra side and you get undefined, there's a chance that that triangle is impossible. All right. So that concludes section 6.1, laws of sines. In section 6.2, we'll get into laws of cosines. If you have any questions, as always, please feel free to contact me and have a great rest of your day.